Hello everyone, this video is intended for anyone planning to scratch build a swamp boat. A scratch build, for anyone who hasn't heard the term before, is when you design and engineer everything except the electronics. If you're an amateur like me, I'm no engineer. Scratch building something like an RC car, forget about it, it's too hard. Scratch building an RC plane, that is possible. You can, scratch build a simple foam design, but frankly, you can buy a simple foam plane without the electronics for really cheap, like 30 bucks. So it begs the question, why would you bother? Scratch building an RC powerboat or a sailboat, I've done it. It is possible, but the design is really tricky. It's, you can spend a long time designing and building something for it to not be very good at the end. But scratch building, if you want to scratch build something that could be as good or even better than something you could buy, I would highly recommend the swamp boat. It's an excellent go. I'll just explain what a swamp boat is. So it's a boat. It's designed to go on water. It's got a fairly simple flat hull, and it's powered by a propeller that pushes the air. That's a swamp boat designed to go over reeds and lily pads and that sort of stuff in swamps. This is the first boat that I made, so I'm going to talk you through what happened with that one, some of the problems and design mistakes that I made that I then tried to fix in this one, the second boat. So this first one, it's made of plywood and balsa wood. So the hull, sides and bottom and back are made of plywood, and then the deck is made of balsa wood, except this bit up here is plywood for strength. To start with, that balsa wood was not necessary. I did it to try and keep the top of the hull light because I was worried about it being top heavy and flipping over, but frankly it's also low to the water anyway that you don't really need to worry about that. So I should have just gone ahead and made the top ply as well to make it nice and strong. It's just all glued together. You can see it's basically a rectangular box with a scooped up front end and flat sides. Now those flat sides are the first big problem that I came across. They're a problem because as the boat goes through the water, as it starts to pick up speed, what would happen is it would hit little ripples and little waves in the water. It would start to get a little bumped from side to side. As it would go to the side, it would dig into the water and then really violently throw itself back the other way, and you would feel like you're going to flip it over. I never did flip it over, probably because everything is so low, but that's what it looked like it was going to do. So those straight sides were a mistake to start with. The next thing is the hatch. So you can see I've got a hatch here. This is mainly for the battery, so it's an aeroplane going over. So when I first installed this hatch, I actually installed it much further forward. It was right out the front here, where the hatch used to be. I had this idea that I needed to balance the boat front and back, like I needed some weight up the front. That turned out to be completely wrong. You actually want the weight as far towards the back as you can, like at least behind halfway on the boat. So I moved that hatch, moved the battery back as far as I possibly could, and that really helped things. So when I had the weight up the front, as I would pick up speed and apply more power, the boat would start to nosedive and it would actually try and drive itself underwater, move the weight towards the back, and that doesn't happen anymore. The second thing is the servo here. You see it's got just a very small servo. That's fine. All it has to do is turn this rudder, so it works pretty well. Then I'll have a look at this motor mount here. You can see this is just made of plywood glued together and bolted down to the deck. I would really recommend doing this. So this is like a modular design. I can just undo those bolts and take the whole motor and motor mount off. I would recommend that because if you want to change something about this motor, you don't want to be messing around with the rest of the boat. So modular design for the motor mount was a good idea. You may have noticed this looks like a pretty big motor for not a very big prop, and you'd be absolutely right. When I first designed it, I had a much bigger prop on here and it was 3 blades. But then I learned about torque rotation. So what would happen is when it was spinning this big 3-bladed prop, is that when the prop was spinning in one direction, it would try to rotate the boat in the other direction. that happened to such an extent that by the time you got to about half power, half throttle, the boat wouldn't turn in the other direction. So it would only turn in the direction that the torque rotation was trying to turn it, and it wouldn't turn the other way. Changing to a smaller prop fixed that up just fine, but I left the big motor on it because whatever. Finally, the rudder design here, you can see it's, you know, square at the bottom, but it's got this angled cutout piece at the top. That's just for looks. I thought it looked cool. It would probably work just as well if it was just a complete rectangle. So that's boat number 1. This is boat number 2. I'll just turn it off. So boat number 2, I tried to fix up those problems, starting with this hull. This hull is made of fiberglass. So I use polycarbonate to like sheets to make a mold, and then I fiberglassed it all with polyester resin. The deck, I carried over that mistake from the first one. The deck was still made of balsa wood. It was weak. Every time you'd have a little accident, it would crack. I fixed that by eventually just pouring a layer of epoxy resin over the top of the deck. So that fixed that problem. Now it is strong and flexible. So plywood is perfectly fine, nothing wrong with that. But you know, if you can work with fiberglass, I would recommend that because it works really well. Then I went for, turn it around, I went for angled sides on the hull. That solved that digging in problem entirely. This thing runs in a straight line, turns, does everything beautifully, never digs in. It's also got some small, very small fins on the bottom here, just to help it tracking straight, which it does. It tracks like it's on rails, but it probably does that because it also has a gyro in here. I don't think that's necessary, but boy, it really helps to get it to track in a straight line. You might notice that it's not run on a prop. It's using an electric ducted fan here. This is quite a small electric ducted fan, and it's only running on a 3S battery, so it's not that fast really, but it works perfectly well, the electric ducted fan. A prop would probably be better, but the electric ducted fan works well. Big mistake with this one though was this servo. I tried to be a bit fancier and I tried to sort of hide the servo underneath the deck here, but then of course I poured epoxy resin over the top of it, so I don't know how I'm going to get that servo out. It works at the moment, but it is making some funny noises, so when it finally breaks, which I'm sure it will, I'm actually not sure how I'm going to get it out of there. In conclusion, these things are a lot of fun and they're not that hard to build. They run on water or on land. They will run over weeds, over lily pads. So if you've got a piece of water that's got is choked up with weeds, you don't have to worry about that. It'll just run straight over the top. But it will run on land as well, particularly wet grass. So one of my favorite things that my daughter and I do is after some heavy rain, we find a big grass area with lots of puddles in it, and it runs over all that stuff, no problem. So there you go. There's DIY scratch building a swamp boat. I hope you can learn from my mistakes.